Hello, Pirates. Today's topic is the carbon cycle. For the carbon cycle, today we're looking at how carbon cycles through ecosystems. So this is another one of the biogeochemical cycles. So just like water cycled through the abiotic and biotic components of an ecosystem, so does carbon. And water was essential to life. If you think back to your properties of water for controlling body temperature, for regulating things like the climate, and then all chemical reactions are happening in cells and everything is flowing in and out of cells, mostly suspended in water, the universal solvent. So carbon, also very important to life. When we talked about our macromolecules, the macromolecules are all carbon-based molecules. So think like carbohydrates, carbon and hydrogen. The lipids, carbon, hydrogen, and oxygen, just like the sugars. And then for the proteins and nucleic acids, carbon, hydrogen, oxygen, and nitrogen, and then carbon, hydrogen, oxygen, nitrogen, and phosphate for our nucleic acids. So carbons are really important as far as it's kind of like the duct tape of life. It holds everything together. So, you guys are mostly water, but if we squeezed all the water out of you, what would be left is carbon for the most part. So we're going to look at how carbon cycles between the biotic and the abiotic components of the ecosystem. Now, we've talked about some processes that involve carbon this year, and we'll talk about a couple more. But ultimately, we are setting the scene here for the carbon cycle. We have a little forest on the left, and basic carbon cycle. If you think about it, there is carbon dioxide in the atmosphere. So we have atmospheric CO2, just like we have atmospheric oxygen or nitrogen gas. So we have atmos in the atmosphere. And this carbon dioxide is going to leave the atmosphere, a abiotic component of the ecosystem, and it's going to make its way into plants where it's going to get into the food chain, correct? And you get your carbon from eating other things, okay, for energy. So with this process that takes CO2 out of the atmosphere and puts it into living things, it's where it's going to start becoming part of the food web, is the process of photosynthesis. And if you guys want to remember that equation is, carbon dioxide and water going into the plant are going to produce the glucose and the oxygen that's going to come out for breathing. So carbon going into the plants through photosynthesis. Now, the opposite side of that is how we put carbon dioxide back into the atmosphere. So things like ourselves, so all living things use the energy that they eat in the food chain, whether it's us or a deer. I'm going to draw a really bad stick deer here. So here's my little deer friend. I could have made the guy a dog instead. Okay, so here we have the deer. And where we put things back into the atmosphere, that CO2 back into the atmosphere is through respiration. So atmospheric CO2 going back into the atmosphere through the process of respiration. Carbon dioxide also diffuses from areas of higher concentration to lower concentration. So we also have phenomena where we have carbon dioxide that is higher in the atmosphere diffusing into the ocean. So the ocean is what we call a carbon sink because it stores carbon dioxide. So here we have diffusion, moving CO2 in and out of the ocean to the atmosphere. And so down here we have dissolved CO2 in the water, and then in the atmosphere we have carbon dioxide gas. Now, when we look at the carbon cycle, this is pretty much how the carbon cycle works right here. Okay, so it's a nice balanced system, carbon dioxide being removed from the atmosphere, carbon dioxide moving back in. So what we're concerned about, how humans have impacted this. So we're going to look at a couple ways that humans have impacted the carbon cycle. And ultimately, our big contribution and our big issue is that we have increased the amount of carbon dioxide in the atmosphere. Okay, so we have increased the levels of atmospheric CO2, and you're going to look at just how we've done that in a little bit. But when we've done this, one of the ways that we've done this is at some point we figured out how to burn living things. And when we burn things, we get energy. And that energy is important to staying warm, I don't know, cooking our food. So a lot of energy or CO2 gets put out back into the atmosphere through combustion. Okay, or like open burning. So we're open burning things. It could be a forest, it could be just a fire. Another thing that we figured out over time is that when the trees and the animals and the algae in the ocean, because even the algae dies, when all this dies, it is going to decompose. So everything eventually decomposes. So decomposition. And what's going to happen is with decomposition, this stuff is going to turn into things like coal and oil. So we're going to end up with fossil fuels. And what humans figured out about fossil fuels like coal, oil, and natural gas is we figured out that we could burn them for energy and have more energy than if we were just burning logs and having a typical old-fashioned fire. So what we did, we figured out how to get a lot of energy. So we still have some coal-powered power plants, although there are fewer of them today than there used to be. We use gasoline in our cars. This would be combustion. We use fossil fuels in our factories to power our cities. So just burning fossil fuels. And we're burning up the carbon and things from millions of years ago. So we're burning all these fossil fuels that we pump up to the surface for energy and, transportation. And what we have happening now is when we look at the carbon cycle isn't quite so much imbalanced. In addition to that, we're also deforesting. So our carbon sinks are things that taking in carbon are also becoming damaged. So over here, I'm going to have some deforestation. So what we have is we've created an imbalance in the carbon cycle. So we're getting an increased amount of carbon dioxide from a couple of things. So things like deforestation, open burning, air pollution from cars and cities, even something like respiration, but we're not going to ask you to stop breathing. All right, overall, this has created an increase in atmospheric CO2. Now, why this is of concern is when there's too much carbon dioxide in the atmosphere is going to hold more heat. And so I'm going to have you guys watch a couple videos on climate change, and ultimately this leads to climate change. And when we think about our climate changing, the big changes we're seeing is that things are getting warmer. All right, so with this, we're seeing our climate change as a result of increased carbon dioxide levels. What you guys are going to do is you're going to look at some of the evidence for climate change. You're going to think about solutions. What are the things that we need to do to reduce the impact of climate change? And I want you guys to just kind of pause this, go do the other things, and then come back in a second and look at some of the solutions. So pause, do the other stuff, come back, and we'll go over the solutions. All right, you're back already. Nice. All right, so when we look at solutions, we need more fuel-efficient transportation. Honda, for example, promised, a carbon-neutral line by 2040. Okay. So as we move into the future, our transportation systems are going to have to change to burn less fossil fuels. So we put less CO2 into the atmosphere. We need to reduce open burning. And not just your campfire by your house in the evening, but we're talking about large-scale forest fires like slash and burn to put in agriculture. So they burn the rainforest in order to put in agriculture fields. We need to think about that practice and reduce and do this more sustainably. We need to use more renewable energy to reduce the amount of carbon dioxide in the atmosphere. We need to plant more trees. which is reforestation. Carbon sequestration is another process where someday we might be able to, and there's scientists working on this, and some of it actually in practice now, where we're taking carbon out of the atmosphere and then we're storing it in the ground, where you can kind of turn it back down into like almost like a rock. Another thing is the more people there are, the more energy and resources we use. So this is really important that we decrease the birth rate so that we have fewer people using fewer resources. And then you guys can kind of think those same 4 R's, the good old reduce, reuse, recycle, and reclaim. Okay? The 4 R's are always important. So less of anything is good for the environment, and it also saves money. All right, you guys have a good day. Look at the data, watch the videos you have there on climate change. We'll probably spend a little bit more time on climate change after the EOC because it's a great and interesting topic. And I hope you have a wonderful day.